So example 4 says we have a large pile of coins consisting of pennies, nickels, dimes, and quarters. There is a lot of each one of them, at least 20 coins of each. The question is, how many different collections of 20 coins can be chosen? Okay, so let's make a little diagram to understand what's going on here. So this is my diagram. So there are pennies, nickels, dimes, and quarters, and this time I have to choose 20 coins. So I can choose some pennies, maybe a couple of these, some nickels, some dimes, some quarters maybe. Okay, let's see. I needed to add up to 20. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10, 11, 12, 13, 14 so far, and we need 6 more. So 1, 2, 3, 4, 5, and let's say 6. There you go. So that's one possibility. Okay. So at the end of the day, basically, what did I do? I had to pick 20 X's and put into 4 little boxes, basically. So there are 4 groups, and there are 20 choices to be made. So according to my formula, there are how many choices? Well, there are basically 4 plus 20 minus 1. Choose 20 possibilities. Okay, so why 4 plus 20 minus 1? 4 because there are 4 groups, but we only need 3 dividers to separate those groups. That's why I have to take away the 1. And how many X's did I have to pick? I had to pick basically 20 X's. So hopefully this is kind of reminding you of what we did previously in the last section. So if you want to think of it in a different way, this is pretty much how you can think of it. You can think of it as having to pretty much pick where the 20 X's go in 23 different positions. So if you have 23 different positions, you can put some of them as X's, you can put some of them as slashes. So that means you picked 4 pennies, and now you're about to pick some nickels, and you pick 2 nickels, and so on and so forth. So it's a combination kind of a question. This is the reason why we call the multi-sets also are combinations. Okay, now in the second problem it says how many different collections of 20 coins chosen at random will contain at least 3 coins of each type. So again, let's make a diagram and see what's going on there. Okay, so this time, since I have to make at least 3 coins of each type in my collection, then that's predetermined. I don't have a choice there. But how many more coins can I pick up? So remember, I'm choosing 20 in total, and already 12 of them are accounted for. So I'm only controlling the last 8 coins. So I could put those all in the pennies section. I could put some of them in the dime section maybe. I could put some in the quarters, some in the nickels, or whatever. Okay, so basically in this case, I only had 4 groups, but I only had 8 choices to make. And the total this time is 165 possible coin different collections, basically. Okay, so finally, what's the probability that a coin collection of 20 coins will contain at least 3 coins of each type? So the probability of having at least 3 coins of each type is going to be some sort of a fraction where we have the 165, because that's how many coin collections contain 3 of each coins at least, and divided by the total number of selections. How many total? Well, 1,771. So 1,771, and let's figure out what the number is, turn it into a percentage. So I'm getting 9.32%.